A warm good morning to one and all. Today we are going to discuss on the topic random variables. Variable means which varies, that is which changes. What are all the things that change in our day to day life? What not? Everything changes. Temperature changes, heights of the students changes, marks of the students changes. The change can be predicted is called a variable. The change which cannot be predicted is called as random variable. Random variables are of two types, discrete random variable and continuous random variable. First let me explain about discrete random variable. The change that is countable, is called as discrete random variable. That means there will be change, the change can be counted, it takes only integer values. That is, for example, marks of students. In our college, marks will be rounded off to a integer. Generally, marks will be taken in integers. That is, next, in case of number of students in the class, number of mangoes in a basket, all these come under discrete random variable. A variable which takes finitely or infinitely countable number of values is called as discrete random variable. You may get a doubt that how infinite can be a countable, that is stars in the sky. Stars in the sky we cannot count, but we are sure that they will not be in points. If anybody says that the stars in the sky are 5,72,842.32, immediately we will say that it is wrong, because as we know or do not know, those are infinite numbers, but we will be sure that they are not in points. That is what is called discrete random variable. And continuous random variable takes its values in a particular limits, and in a particular limits means it takes integers as well as decimals. In case of heights of the students, 5.4 inches, 6.2 inches, these are all heights of the students, and this can be taken as a continuous random variable. Or the temperature of a place, Vijayawada temperature today is 24.8 degrees Celsius, then it is continuous random variable. Continuous random variable is called as a measurable variable, whereas discrete random variable is called as a countable variable. And again we are dealing with two kinds, univariate data, bivariate data. If one variable is sufficient to make the analysis, then it is called as univariate analysis. That is, income of a person leads to the standard of living of that person. That is, income is a univariate. And whereas coming to bivariate data, bivariate means surely you need two variables to make the analysis. For example, if anybody says you are obese, that means you are fat. On what basis they are saying that you are fat? That is basing on height. Basing on height only we can decide that you are underweight or overweight, or exactly your weight is maintained. That is what is called bivariate data. And in case of rainfall and yield of the crop, if this year the crop is very good, the yield is very good, how can you say that the yield is very good? There are so many factors influencing the yield of the crop, but mainly the rainfall, which is not in our hands, that is under nature. So, it is a bivariate analysis, and bivariate analysis is dealing with correlation. Next, coming to univariate analysis, if x is a discrete random variable, its function is called as probability mass function, and it is denoted by p of x. Discrete random variable function is called as p of x, and it is a tabular form. X takes values x1, x2, so on xn, and probability of respective xi is p of xi. A statistical table can be called as a probability mass function only if two conditions are satisfied. One is each probability should be greater than or equal to 0, and the total probability should be equal to 1. As we know that the limits of probability will be always in between 0 to 1. That is about probability mass function. The probability distribution function of a discrete random variable is called as a step function. Coming to the continuous random variable, a continuous random variable function is called as probability density function, and it takes its limits in a it takes its values in a limit, and its function is denoted by integral minus infinity to plus infinity f of x dx. And a function can be called as a probability density function if and only if its total probability, that is the probability within the given limits, is equal to 1, and each probability value should be greater than or equal to 0. Next, the probability mass function can be shown like this. This is called as a joint bivariate probability mass function. Till now we have seen univariate, now this is bivariate. This is a probability mass function and it is of tabular form. In this, Pij represents probability that x takes ith value and y takes jth value, then its probability is Pij, and the column totals are called as marginals. The total of the totals should be always equal to 1, that is total probability should be equal to 1. This is called as joint probability mass function, that is bivariate data, and marginals of the variable is p of x is equal to xi, that is equal to p of x is equal to xi or p of xi, and marginal of y is p of y is equal to yj or p of yj. In case of continuous data, we call it as joint density function, that is double integral f of x comma y dx into dy, and its marginal function is f of x dx, and its y's marginal function is integral minus infinity to plus infinity f of y dy. And if we want to say that the two variables are independent, f of x comma y double integral f of x comma y dx dy is equal to f of x into f of y, then the two variables are said to be independent variables. And in case of discrete random variable, p of x comma y is equal to p of x into p of y, then the two variables are said to be independent variables. If we want to calculate the mean of the given variable, that is called as expectation of x. Expectation of x is given by summation x into p of x, that it is the product of each variable with its probability, then it is called as expected value of that probability function. And in case of continuous random variable, expectation of x is given by integral x into f of x dx. In case of joint probability function, if we want to get the marginals, f of x comma y is equal to, we need to integrate the joint function with respect to the other variable, that is if you want f of x, you have to integrate the joint function with respect to y, so that we can get the marginal density function of x, and in the same case of y also, joint function of x and y should be integrated with respect to the x, then we will get the marginal distribution function of the y.